A good technique of integration to know and have in your tool belt is integration by parts. And you normally use integration by parts when you have an algebraic function and a transcendental function, such as e to the x or ln of x, or also when you have trigonometric functions. So the formula for integration by parts is derived from the product rule, and the formula is the integral of u dv equals uv minus the integral of v du, where u is something easily differentiable and dv is something easily integrable. And so key things that you should look for when thinking about using integration by parts are e to the x, ln of x, or trigonometric functions like sine x, cosine x, tan x, and also inverse trig functions like arcsine x and arctan x. So the first example that we're going to do today is just a basic integration by parts example, so where you have an algebraic part and a transcendental part, so x e to the x. So first you're going to decide that u is x, because x is easily differentiable, so let u equal x and du equals dx. Now e to the x is the part that's easily integrable. Let dv equal e to the x dx, and when you integrate both sides, v equals e to the x. So now that we have our u and our v, we're going to just follow the formula for integration by parts. So the integral of x e to the x dx equals u times v, which is x times e to the x, minus the integral of v e to the x du, which is dx. So we're going to carry down our x e to the x and minus the integral of e to the x. The integral of e to the x is e to the x, and we add our plus c. Second example we're going to do is a more complicated example where you have e to the x cosine x dx. So in this case, it's kind of hard to decide which one you're going to let u equal and which one you're going to let dv equal, but you usually always pick u as a trigonometric function before an e to the x function. So we're going to let u equal our cosine of x. So if u equal cosine of x, du is going to equal negative sine of x. And then our second part, we have dv equals to e to the x dx. So v, when you integrate both sides, is going to equal e to the x. So the integral of e to the x cosine x dx equals u times v, which is e to the x cosine x, minus the integral of v du, which would be minus the integral of e to the x sine x dx. Now, the first thing I want to do is fix that double negative problem. So if you bring the negative outside of the integral, minus a negative is a positive. So e to the x cosine x plus the integral of e to the x sine x dx. And so now we're left with the second integral, which we still don't know how to integrate, unlike how we had in the first example. So we're going to have to do integration by parts again, and we're going to follow the same method. So we're going to let u equal sine x, du equal cosine x, dx. And then dv will equal e to the x again, and v will also equal e to the x. So the integral of e to the x cosine x dx equals e to the x cosine x plus u times v, so e to the x sine x minus the integral of v du, so minus the integral of e to the x cosine x. And so here we encounter a problem again, because we still don't know how to integrate e to the x cosine x. You can see that the part left of the equal sign is the same as the integral we have on the right, so we're going to add the integral of e to the x cosine x to both sides in our equation, and that's going to allow us to solve this problem. So you end up with 2 times the integral of e to the x cosine x dx equals e to the x cosine x plus e to the x sine x all we have to do to solve our equation is divide both sides by 2. So the answer to this problem, the integral of e to the x cosine x dx equals e to the x cosine x plus e to the x sine x all over 2.